Hi guys, we're just going to now wrap up the discussion on linear functions, and I'm going to talk about one of the simplest really algebraic concepts, and that is finding the equation of a linear function. Okay, so that's the talk here, and you can see I've got two linear functions or sketches there on the Cartesian plane, and we are going to find the equations that represent these sketches. To start with, I'll start with the one where points are given. So you must remember one important thing. The general form of the equation is y equals to ax plus q. The first important thing that I'm going to find is a, which is basically your gradient. We know that by now, and you know that the gradient is changing y over changing x. And so I'm just going to say 4 minus 1, and so that's going to be plus, and then I'll have minus 5, and I subtract 2. This is 5 over 7, so I've got a negative 5 over 7 as my gradient. So I substitute that into the equation, negative 5 over 7x, that's what I've got, plus q. Now to find the q, which is what, by the way, I hope you remember, it's the y-intercept. So to find this y-intercept, and if you look at the diagram, this is the point that I'm trying to find. Okay, this is the point that I'm trying to find. To find it, there's no point in substituting 0 here because I'm going to get 0. I'm going to get q equals to y, but what is y? I need a value. So I'm going to substitute one of these points, either point D or point C. Any of them, it will work. So I'm going to take the simplest one. I'll take 2 and a negative 1. So if y is negative 2, negative 1, then x is actually a 2 there. So plus q. And we can see now what we've got here. We've got a negative 1 plus 10 over 7 equals to q. And this is a time where you use or take advantage of the instruction in the exam paper that non-programmable calculators may be used. And of course, this will give you 3 over 7. And that's something like a 0.44. So that's what that number there is. In fact, I can go ahead here on GeoGebra and create a point here, okay, and ask GeoGebra to show me the label of that point. Okay, it's point E, but I want to know the value. So I'll ask GeoGebra here. There it is 0.43, and that's exactly what I have on the calculator. That's what 3 over 7 is. So you can see that the algebra does actually talk to what you have in the picture. Therefore, for this line here, we have the equation y equals to negative 5 over 7x plus 3 over 7. That's okay, we are done. Let's come to the next equation, and there is some terminology that I need you guys to pay attention to. In the first equation, by the way, we say this equation, because of this point E now that I have put in, we say the equation cuts the y-axis at the point E, okay, which is 0 and as 3 over 7. We don't have that coordinate, but we can see it still cuts the x-axis. So whenever your straight line crosses either the x-axis or the y-axis, we say it cuts the axis. So in this case, at B here, we can see the coordinates of B is 0 and 5. So it cuts the x-axis at y equals to 5. It cuts the y-axis, sorry. Here it cuts the x-axis at x equals to negative 2. You need to get that terminology correct. Very, very important. Okay. Because some questions will come in that sense. They will tell you a line passes through some point and cuts the axis at what point. You need to make sense of such information, all right? So when they say it cuts the y-axis, it means you have a y-intercept. If it says it cuts the x-axis, it means you have the x-intercept. And you know at the y-intercept, x is 0. At the x-intercept, y is 0. Very, very important things that I'm repeating here. I might be boring you, but I want this to stay in your mind. Dream about it if possible. So let's go for this. We look for the gradient, and we can see basically gradient is going to be y divided by x. So it's going to be, now notice, 5, okay, over 2, not negative 2. Okay, notice that, because I'm actually having here 5 minus 0, and at the bottom here, I am having 0, okay, 0 minus a negative 2. That's what I'm having. So that's why I end up with 5 over 2. But what really made me to do this is to notice that actually there's no difference in y and x, because we've got a 0 on one coordinate and 0 on another coordinate. So, but then because my gradient is positive, because the line goes this way, I just knew I've got to have a positive. So that theory, you can always use it, all right? So we've got the gradient. Gradient is 5 over 2. So that means the equation is 5 over 2x plus some q. I got to find the value of q. Again, you can take either point A or point B. Okay, so let's take point B. I'll take that because, yeah, it doesn't, the x value is 0, so I want to do away with this fraction. So B, I know is 5, so I've got 5 over 2 into 0 plus q. So I can see q is equal to 5. In fact, for this one, even if you did not really calculate q and you just took it from the fact that we've got a y-intercept and q is a y-intercept, that was still perfect. Okay, then yeah, so there we are done. All right, so please guys, be on the lookout for this. There are other examples that I could have done, but I will not, because of the comments or the remarks that I have already made. Okay, the remarks that I have already made are enough for you guys to be able to tackle the other questions that might possibly come. So keep well. I'll send that exercise in the group chat, and I hope you manage. Cheers.